Hello everyone. Today is the 32nd day of Leetcode 75 challenge. Let's begin with the 32nd question. Question 2130. Maximum twin sum of a linked list. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So you are given head of a singly linked list with an even number of nodes. Fine. In this list, the twin of the ith node is n minus 1 minus ith node, where n is the total number of nodes. For example, if n is 7 and if I is 0, then the twinth node will be 7 minus 1 minus 0, which comes out to be 6 because the indexes are 0 based, right? That's the thing. So first index and the last index, then the second index, then the last second index, this way. The twin sum is the sum of the node and its twin. Now, your task is to find the maximum twin sum among all such pairs in the linked list. Return the maximum twin sum as the result. So we just have to find the maximum sum of the twin pair. If these are the thing, right? 3, then 4, little bit 2, then 3, fine. So this will be a sum. Then this gonna be a sum, right? I took odd numbers, but if it is in even, so this is the twin pairs, right? Okay, great. So what are the constraints for the problem? The problem of nodes in this link is even integer. It goes from 2 to 10 to the power 5, and the node value could be from 1 to 10 to the power 5. Right? So just keep in mind the number of nodes given will be even so that we could make the pairs. Right? Now let's move to the next slide. Let's understand the input output of the problem. So since we are given here 5, 4, 2, and 1, right? So these are even nodes. So according to the question, uh, 5 and 1 is a twin node, sums out to be 6. 4 and 2 comes up to be a twin node, so sum is 6. So maximum for both is 6 itself. So our answer is 6 here. Fine. Similarly, here only two nodes we have, so we add both of them. We get 1000. Sorry, whatever it is. It is 1 lakh and 1. Fine. So this is what we get. So it's simple. It's nothing complex in it, right? So now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Fine. Let's start by understanding the goal much clearly. Fine. So we are given the head of a singly linked list with even length. Let me make it up. 4, 5, 6. Fine. So our goal is to find the maximum twin sum, the sum of pair of nodes that are equidistant from the start and the end of the list. So basically, it says the same thing. This and this are equidistant from each other, right? A and B. If you see, C and D are also equidistant from each other, right? So basically, we have to iterate from back and front both. That's the thing. So this is done, right? So what could be the brute force or the first thing which could come to our mind? If we traverse the complete linked list and store the values in a list, fine. 1, 2, 3, 4, 5, 6, fine. And after that, we could use two pointer concept and iterate from back and forth, from front and back simultaneously and get the sum for the twin pair. And from there, we could get the maximum value, right? So this could be done, but it will take O of n space as we are storing the values in the list, right? So we are not supposed to do, or we are not supposed to use this O of n space. But eventually, even though the problem or the solution which we come up with, the brute force, is correct, but we are not able, but we are not allowed to do so, right? So we have to aim for more optimal solution of O of one extra space, right? That is the thing. Now let's try to visualize the process, how we're going to do it with O of one space, right? So suppose we have a linked list of 1, 2, 3, 4. Okay, and it points to none, of course. So what are the twin pairs for this? It is 1, comma 4, then 2, comma 3, I guess, right? Let me take a longer linked list. Let it be 5, let it be 6. Pairs would change now. So pairs would be 1, comma 6, 2, comma 5, of course 3, comma 4, right? So sum for 6 is this one is 7, 5 plus 2 gives me 7. 3 plus 4 also gives me 7. Fine. So this is it. So what we could think of, let's try to imagine that what if I remove these arrows, right? Or these pointers. Okay. And if I point them in opposite direction this way and point this to a none value, we got two linked list. Fine. Okay. How this will help us? This will help us if we run from the head of this linked list, and head of this linked list will become 6 now, right? And if we add these values and then come front or come further until and unless this linked list, of course this linked list points to none, right? So this way we could use the two pointer concept which we usually use in our array questions here and complete our solution. So this is basically concept. So what we are doing here, we are basically reversing the half of the linked list here, right? So point one, we reverse the linked list. Fine. What could be the second point? Second point could be how you will come to the how you will decide when to divide the linked list into half and reverse. So we could use the concept of second part, slow and fast pointer. Fine. From this we could find the mid node. Fine. So this way we could find the midpoint of the linked list and then reverse it and then use the concept of two pointer in this case, right? Let me write it down. So third pointer will be using the concept of two pointers. Fine. So first is reverse the linked list, second is slow fast pointer to find the mid, and third is two pointers. Okay. So okay, we know we have to do this. How we can simulate this now, right? So first we could use slow fast pointer. For example, in this case, 3, 4, then 5, then 6. Fine. Slow, fast. Fast will come here in next iteration. Slow will come here. The next iteration, fast will move here, and slow will eventually come here, and this will go out of the loop. So this is the midpoint. Fine. We got the midpoint. Great. Now we could implement the logic of reversing the linked list. So if you reverse the linked list, which will be basically uh, reverse linked list would be getting from slow dot next, right? So we will reverse this. Done. After that, we could iterate. We could bring the slow pointer back to the head, and this will be the head from the reverse pointer, reversing the list. Fine. Great. So this is what I have written here. We traverse the list together for each pair of the nodes. We compute their sum now. We keep the track of the maximum sum using any variable. Now we continue this process until the second half, since it's a shorter segment after reversal, because this will eventually point to a null value, right? So till that time we traverse the linked list and return the maximum of the two. Fine. So this is all about how to reverse the linked list, then find the midpoint, then reverse the linked list, then use the concept of two pointers, right? This way we could solve our solution very easily. What we figured out, we used fast slow pointer technique to efficiently find the middle of the linked list. Great. We applied the reverse linked list concept to reverse the second half of the list in place, avoiding the extra memory usage. We then use two pointers, one starting from the head, other starting from the reverse second half, compared to in nodes values. Now, this approach runs in linear time complexity and constant spin, making it optimal linked list problem, right? So what we learned, fast, slow pointer, concept of reversing string, then two pointer concept. Great. These are the three things. which help us to solve this problem. Right? Now let's move to the next slide. I hope you understood the intuition. Now, since you got the intuition of the problem, let's look into the approach how we're going to solve it. Fine. First step comes with finding the middle of the linked list. How we gonna do it? We're gonna use slow and fast pointer concept here. Slow moves by one step at a time and fast moves two steps at a time. For example, if this is a linked list, slow is here, fast is here, fast will cut down and come here, slow will cut and come here. Similarly, fast will go out and this is the midpoint. So we're gonna reverse this part. Fine. This is what is written here. And why we are doing this to help us to reach the middle of the linked list using two pointer technique efficiently, right? So that we can use the two pointer technique easily. Since this list has even number of lengths, slow will point at the midpoint just before the start of the second half because this is the midpoint and slow's next will be the one which we will be reversing. Fine. So this is how we will clear our step one by finding the middle of the linked list. The second part is reversing the second half of the linked list. So now slow dot next consists of the second half of the linked list. Fine. So we will reverse this in place. Fine. We assign why we do this. Reversing the second half allows us to line up twin nodes from start and end of the direct comparison without using any extra space. Right. So I will explain this step two further. Now, step three is how we will reverse the second half of the linked list in a detailed manner. So first thing, this complete problem has been solved in 31st video. You could check it out in my playlist of 75 challenge. You could find it there. Fine. But then also I will try to explain it in a brief manner here how a reversing of a string is done. Suppose this is a linked list. So this points to null. And when we reverse it, this points to null here. Then 1, 2, 3, 4, 3, 4. Fine. So this is the output, right? From here to here. How we do it? We try to have previous, no, previous. We will create a linked list or previous node. We'll point it to none. Then we will have current. It will iterate the complete linked list. It will point to head. In this case, basically slows next. Fine. Here it is written. Now we traverse the linked list. How we traverse the linked list? While current exists. Fine. What we do? We create another pointer next and store current dot next in it, and then current dot next points to the previous pointer. Then previous takes the value of current pointer. Then current pointer goes to the position of the next pointer. Fine. So how this is done? Let me tell you. So what happens is that previous is pointing to none. Fine. Let me clear this up and show you. So okay, let's see. Previous P means previous. It's having a null value. Please assume it. We have taken it already. Current is pointing here. Now while current is not null, we will iterate, right? So current next is this, right? So and next will come here. Then current's next is pointing here, right? So we will remove that and we will point current's next to previous. Correct? Then previous gets removed from here. It comes to the current position and current gets removed from here. It goes to the next position. So this will be current. Similarly, again, current will next will come here and then this will get removed and current next will point to previous. Of course, it will go here. Then previous will come here and current will come here, right? If you could see, the linked list is getting reversed. So this way, all the pointers will get reversed, and our linked list will get completely, the reversed way. So this is why we are doing here in the step 3. Great. Now, what is step 4? We initialize two pointers to traverse both halves. First head points to the beginning of the linked list, the original path, which is this one, and second points to the head of the reverse linked list, which is this one. Fine. So here it is second S and this is F first. Fine. These pointers will use to traverse both halves of the list and compute twin sum. Fine. This we will understand while we will do the try run. So this is the thing in the step 4. In step 5, we traverse and compute the twin sum, right? So like this is the nodes. Suppose we have already reversed the linked list. Fine. Pointing to none. So fast is here and first is here or fast is here and second is here. So we take the values for both and value fast plus s, fast plus second. Then in the max we store the value, correct, out of which is max. Then we come again here. Then we take the value for this. We add it. We check for the max. And when this points to null, right? So iteration is complete when it sees that it is a none value. So we return the none. So we return the none value in step 6. Right? This is all about the approach and the steps we're going to take to solve this problem. I hope you understood it. Now let's move to the next slide. The code is the exact copy of the approach discussed. Let's understand it line by line. So this is the complete code. If you could see, this is the function for reversing the linked list. And this is the function given to us. And here we are iterating the reversed and the normal linked list. Fine. So let's see what we're doing. We're taking the head of the linked list here. We're pointing previous to none, as I said, current to head. We iterate the complete linked list and reverse it. Fine. And we return the previous because when iteration is complete of reversing, this gets reversed to this gets reversed to this. So previous comes in the last of this value, right? So we have to return this because previous becomes the head of the linked list. Then here, I'm telling again, if you have any doubt regarding the reverse linked list, please watch the video 31 of this playlist. You will get to understand it. And in the main program, this is done, right? Here, if you see, we are using fast and slow pointer, as we explained, to get the mid of the linked list. Fine. When we get the mid, we point slows dot next into the reversing part because in even number of nodes, this is the midpoint. So we send this part of the linked list here. If you could see slows next, because slow will be standing here, slows next is sent to get reversed. Fine. This is what is done here. And then in second, we keep the slows next value, which is this head of the reverse linked list, and first goes to the beginning of the given linked list. Fine. So then we just iterate while second is not null, and we take the values, we add values, we take the maximum sum here, then we go next, next, and we just return. This is all about the code, and it takes complete of O and time complexity and space complexity is O of 1 because you are only iterating here one time in one pass. That's why. Fine. So that's the thing. Now let's move to the next slide. Now, so you have the understanding of the code. Let's look at the dry run of the example. So let's do the example. Okay, so this is done. This is done. Okay, first step, mid part or midpoint, right? Concept use fast, slow pointer. Second, reverse. Third, two pointer knowledge or two pointer concept, you could say PTR. Fine. So slow is here, fast is here. Fast comes here. Sorry, not there. Here, slow gets removed. Slow comes here. Fast goes out of the iteration and slow remains here. This is done, right? Now I will clear this up. Yeah. So now we know that for reversing, for the reverse function, we used to take slow dot next. What is slow dot next here? This one, right? We will take this node now. We will reverse this linked list. We have this 3 pointing here, this pointing to none, of course. So if you remember, we have a previous node pointing to null. Let it be null. We had current here. Fine. So while current is not null, next was standing. Next, what we had? Next equals to current next, right? If you remember. So next is standing here. Great. Then we had current next pointing to previous. So this pointer will get removed from here. This will point to previous pointer. After that, previous comes to current, and I will write it here. Current takes the after that next. It comes to the next position basically. Fine. So what will happen? Previous will come here, current will get removed and come here. Fine. So we'll clear this up. This one also. Okay. Now again we come to the next step since it is not null. So the current next will go to the current next, which is none, right? So it will go out of the scene. Then current next is pointing to will point to previous. This will get removed. It will be pointing here. Then previous will come to current's position. Now current will go to next position, which is of course it is out of the loop, so it will get removed. So this is done. We remove it. So this gets removed completely. And what we do, we return the previous pointer. Fine. So after doing the reversing part, the linked list will look like this. Is pointing here and 2 is pointing to none. 3 is pointing here. Fine. That is done. So midpoint finding is done, reversing is done. Now we will do a 2 pointer. What we can do is that we could bring the slow pointer again to the head, and we still have it here, right? So that's the thing. So we will just take both of their value 4 plus 3 gives me 7, right? So max has the 7 value as the max right now. Great. So it will come here, then this will also come here. 2 plus 2 gives me 4, right? Let me write it here. 2 plus 2 is 4. But it is smaller than 7, right? So we cannot change it. So previous comes again here, but it reaches null, so it cannot be iterated more. So we come out of the loop and we return max, which is 7 in this case. So this is complete dry run. I know it includes three complete topics like finding the midpoint using fast and slow pointers, then using the concept of reverse, then using the concept of 2 pointers, right? So if you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, how slow fast pointer works, the concept, the approach, and the code. After that, do a dry run by yourself with 2 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now, since we are familiar with the problem and the solution, let's move to the lead code and code the solution. So let's start by here, writing the slow pointer pointing to head, fast pointer pointing to head, while fast and fast dot next next. No, the fast dot next is not none. Slow will go by one step. Slow dot next, fast dot next. Fine. After that, we got the midpoint. So slows next will grab the midpoint value. Self dot. We will write this reverse list function. So dot next. Fine. So let's write this def reverse list. We got self and head is the list node. and we have to return a linked list. Fine, great. So what I will do, previous will point to none, current will point to head, then while current exists, we'll create a next pointer and it will point to current's next value, and current next will point to previous. Previous will come to current's position, and then current will come to the next position, right? And after that, we will return previous. Great. This is done, and we got the reverse from here. So we will keep this in second, no, second pointer, slow dot next. Then first will point to head again, and we'll create a max sum variable, store the values. While second is not null, max sum will be max of max sum first dot val plus second dot val, right? And then we will move first to first dot next, second to second dot next, right? And we will just return max sum. So yeah, now let's try submitting the solution. It got submitted. Now let's finally submit it. Okay, we have successfully submitted our solution. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.